Hi folks, this is Julik, and we're on our second Fishbowl show about Matchbox shaders. And what we're going to do is we're actually going to build us a couple of shaders. Here I have Joel Ozis live with me from Sydney, from very far away, and he's as awake as he ever was. Right, Joel?
I'm getting there. I'm almost awake.
All right, man. So my idea was, now that we have covered a couple of things of how these fragment shaders work, is that we could actually try and make us a couple of very simple Matchbox shaders, and then I could also explain a number of mechanics about them, like how these files that you work with actually look, and where do you look for examples of shaders, etc. So here we have our very simple black frame, basically.
Yep.
And we're gonna build us a very simple BFX thingy. I still call it BFX because I think ConnectFX is just marketing stuff. But basically, the most simple thing that you can do in terms of image processing is this baby that we know and love. It's the colored frame. So you have a colored frame, and then you pick a color, you set, and this is actually the first Matchbox shader that we're going to create by hand. Is going to be the colored frame generator. Okay. So to begin with, what we're going to need is our terminal, which I got right here, and my terminal is set it can be in any directory on your hard drive, and you can also use the Flame terminal if you want to. It doesn't matter. The most important thing is that you need access to your terminal to do stuff. So currently, if I type pwd, I'm located in a directory called code what is Matchbox, but it doesn't matter where I am. The most important thing is that I remember what I got here. And to get started, actually what we're going to need is we're going to create a file, just an empty file, because now this directory contains absolutely nothing. We're gonna say touch, and then we're gonna say color.glsl. Okay. Now, if we type ls, then you will see that it actually contains an empty file, which is called color.glsl. And when we are on a Mac, we can also type this nifty thing in here. We can type open dot, which means open this directory, and then it's going to open this directory in the Finder for us. So we got this file open here. What we're gonna do is we're gonna pull that file into a text editor. Now, just a little warning for people, like a text editor that you use for code is not the same thing as a word processor that you use for documents, like Word. For code, you really need something that doesn't do any formatting whatsoever, but something that allows you to do indentation easily, maybe gives you some syntax highlighting. So
what's a good? I use Text Wrangler. Is that a good one, or?
Text Wrangler is great. I use TextMate. Some people use Vim or VI. Some people use Emacs. The choices are broad. The most important thing is that it doesn't save any formatting. That it allows you to process text as is. You can even use Nano if you want. I use TextMate, and TextMate is actually available to me as a command line application. So all I have to do to open that file in TextMate is I have to type mate and then color.glsl. And we always have auto-completion for file names, so I can just say col and then tab, and then once I type enter, then it's going to open that file for me in TextMate. I'm going to make the font like real big, so that's very visible what I'm doing. And like I said in my previous clip, we're gonna have this function which is the main shading function. It's this one. All right.
Okay.
So the first thing we're going to do is we're going to say main, and then we're gonna need the braces and the braces. Now, a very kind of important thing that you have to know about GLSL as a programming language is that it's strongly typed. Strongly typed, it means that you cannot say that you cannot tell it, for example, to just store some value to a variable and be done with it. You actually have to know what kind of value you're storing into what type of variable. So, for example, if you go to, say, I don't know, hello, it wants my password. Cannot do without. If you go to a console in Google Chrome where you type your JavaScript, for instance, then you will be normally able, like if we go to Joel's site, and we're not going to show any of it except for the address, then you can just type, say, x equals 123, for example, and it's going to assign x to 123. It shows us some junk in here, but this doesn't matter that much. Again, if we say x equals 123, then it's just going to assign the value 123 to x.
So to nothing values.
Well, it's just it doesn't care what you type in. It types them automatically for you. So if we say type of x in JavaScript, then it's going to say that it's a number. So it was smart enough to detect that it's a number when we assigned it, and it just knows that it's a number and all is fine and dandy. And if we say name equals Julik, say, then it's going to know that it's a string, and we say type of name, it's going to say that it's a string. So JavaScript detects these things for you, and the same is true for older versions of ActionScript and Flash, and the same is true for PHP, etc. But that doesn't work for GLSL. In GLSL, you have to explicitly specify what kind of values you are using, except for the cases where you are actually using some value which already exists, and the GLSL compiler just knows what that value, what the type of that value is by its name. And let me just explain how that works out normally when you have typed values, because quite a few people, in my experience, have done some scripting, but not everybody is familiar with using a strongly typed languages, and that kind of might be kind of a roadblock for some. So let me explain how to read those type declarations. If you look at a Matchbox shader, for example, let's look at my lens distortion shader. We're going to go to GitHub, Julik Silence Matchbox, right here. And we're going to click on the GLSL file. Like here you can see those three files that I was talking about, the GLSL, the XML, and GLSL.p. If we go into the GLSL file and we zoom in on this one, or we just make the fonts bigger, then you're going to see that at the top we have the uniforms, which are prefixed with the word uniform, which is called a keyword in programming languages like GLSL. So that's a keyword, uniform. Then we have something which is called float. And float, that's the type declaration, and it tells the GLSL compiler that we're going to have a uniform float variable called kcof, and then a uniform float variable called kcube, and then
those are your sliders, yeah? Ones in your...
And those are coupled to the sliders, but these are internally stored as floats. And float is a floating point value, like, say, 0.15 is a floating point value. Your color value for the color white in black and white is 1.0. That's a floating point value.
Okay.
And 1 is actually an integer value. That's not a float value. So integers are typed as int, and integers in GLSL are signed, which means that you can have negative integers and positive integers. So you can have 0 is an integer, and -1 is an integer, and +3 to 1 is an integer, etc., etc., etc. So if we look at my source code again, then you will see that I've got a uniform float for these distortion values. Then I've got these babies for the chromatic aberration stuff. Then I've got the bool, which is a Boolean value, and it stands for true or false. So you can have some value which is either yes or no. Okay. And this is, and for that you use the keyword for bool, and the key, and some uniform which is a Boolean uniform is going to be configured as a checkbox LED button in the Flame UI, which is handy. And then we have again uniform, and then something called sampler 2D. And a sampler 2D variable, it means a texture. So
based off, like, right next to it, so it's using your input, so whatever we assign. Okay.
Yeah, that's why I'm calling them input 1 and input 2, because these actually represent textures coming on the input tab 1 of your node and the input tab 2.
Okay.
Right? And then again, we have uniform int, override W and override H. Since these are pixel dimensions, I have them as integers, because you're not going to have a pixel dimension, pixel dimension of an image. Your image is never going to be 1024.3 pixels. That's just that's just not possible. So that's why it's typed as an integer. And why it's important to have these values typed is so that in the first place, you're by setting these type keywords, you are actually telling the compiler what kind of arithmetic it has to apply to different values. Because like doing calculations with floats is actually somewhat more involved than doing calculations with whole integers. Also, when you say that something is going to be a float or an integer, you're allocating a different amount of memory for these values, which is also important because floats take up more space than integers, as far as I know. And the next thing that we're going to see in here is that every time I declare some kind of a variable, for example, here I'm declaring a variable called lookup table. Before that, I always got to have a type declaration. And the same thing is going for functions. So if we look for the main function in that shader, because every Matchbox shader is going to have the main function. And on my lens distortion shader, here it is on line 93. That function also has type declarations, and it has a type declaration of void and void. Now, here you need a type declaration to specify that your function is accepting something, but the standard doesn't actually say what your main function is supposed to accept. That's why you put in void, and void stands for nothing, or rather to say, I don't know what that is exactly. Okay, so this sort of implies that you might be able to be getting some value in the future version of the shading standard or whatever, but of now, this is of no use to you. All you do is just you just type it because it has to be in there. It's kind of a boilerplate thing. And also we see that it's got a void type for the return value, which means that this function doesn't return anything. It just executes, and what it does, it assigns to the variable for the output color of the shader. That's all. It doesn't return you any value that you can use externally. Here, for example, we have the function which is called chromaticize and invert, which accepts a float, a single float, and which returns a vec3. And a vec3, it means a vector of 3 values, and you can use vec3s for things like an RGB value or an XYZ coordinate, or anything of that nature. And you can see it as a bundle of 3 floats. Okay, so you have a vec3 is going to be your main type for like an RGB value as a whole. An ivec3 is going to be a type for a vector of integers, and so on and so forth. And since GLSL is made for graphics programming, okay, it's got a number of very convenient shorthand functions to work with vectors specifically. So what we're going to do first, we're going to do our shader, which creates some color as just value assignments, and then we're going to sort of upgrade it a little bit, and we're going to assign the whole vector. Okay, so the first thing we're going to do is we're going to need this boilerplate for our main shading function, So you can just grab it from, we're just gonna copy paste it from here, and we're gonna go into our TextMate and we're gonna paste it right here, okay? And that's already a function. And then we have this magic variable that we're gonna be assigning to. Now the magic variable, as you remember, is something that we set to set the color of the pixel that we're rendering. And here I'm calling it out RGB, all right? But actually, it's called slightly differently, and you can pretty much always find it at the end of the main function in whichever shader you look for, or whichever shader code you are reading. This assignment is usually going to be the last operation of the shader, and here it is right at the end. And this is where, yeah.
Sorry to interrupt, but is it? Would I be correct in saying that, like, you know, if you looked into one of the Matchboxes that ship with smoke or flame, that you can see all the source code as well in the main file?
Yes, yes. It's
cool.
It's not the main file. Main is just a function in the Matchbox file. But Matchbox is not encrypted in any way or not compiled. It's just a piece of source code that you can and should read.
Okay, that's good to know.
That's one of the great things about Matchbox, actually, in my opinion. So, like I said, there is a point in the Matchbox shader where you're going to be assigning the value that you computed for the pixel that you are rendering to the pixel, and this is where it happens in my lens distortion shader, right here. As you can see, the magic variable that it all comes down to is this one. It's called GL_frag color, and it stands for GL fragment color, which is the color of the pixel that we're assigning to. GLSL also supports multi-line and single-line comments. We're going to use single-line comments just for brevity, and they start with a double // So if you type something with a double // it's going to be a comment.
Cool.
Okay.
Cool.
Not going to be processed. Okay. Now to start with, we can actually just grab this baby. And you can see that what I'm doing here is I'm assigning to glfragcolor.rgba, which has to do with a number of properties of vectors in GLSL. But for now, all we're going to do is actually something very simple, is we're going to say glfragcolor.r equals 0.1. And we got to have a semicolon at the end of the line, always, in GLSL, as far as I remember. As you can see on every line, you got a semicolon here and here and here. And then we're going to say GL frag color. Here I'm pressing escape, and TextMate is auto-completing that keyword for me. But I really advise you, when you're dealing with this kind of programming instructions, that you actually type the stuff that is being told, because that helps memorizing everything really neatly. So color.g, and we're going to set our green to 0.2, and we're going to set the GL frag color.b to 1. So we're going to make it a really, really bluish thingy. Then we're going to press Command S, and we know that it's on the file system at this point. And first of all, we're just going to try to load it into Smoke and just see what happens, because if it doesn't load, then we know that we did something wrong, and if it does load, then we know that we're golden. So we're going to just grab us say 1 frame of white, and we're going to put it into the timeline. And we're going to add the connect effects. For the ribbon to show up in Flame shortcuts, I use a Control Tab. And if you use the Control Tab shortcuts, you can actually hide this piece here. So Control Tab.
That's a good one.
So Control Tab and create connect effects. And then I'm going to grab Matchbox and put it in between my input and my output. And by default, when you open a Matchbox node, it drops you into a certain directory, and you can read the path to that directory here. This
But
is
that's not necessary, right? Like you can load these from anywhere.
you can load the Matchbox shader from any piece of your file system that's available to you. So in that case, what we're going to do is we're going to actually go up here, all the way up, and I'm going to actually go to the root of my hard drive, and then I'm going to go to users, and then Julik, and then code, and then I'm going to get to what is Matchbox. Here it is. And here you can see that it's already showing us one empty icon with the nifty word color on that. Okay? That means that it recognized our GLSL file as a shader that it can load, and maybe it will just work. Let's try. Bam! There we go. We have some color output, as you can see, and we have no interface going on, as you can see. Page 1, column 1, nothing is happening. There is no input configuration, nothing whatsoever. Whichever input we pipe into it, it's still outputting us an HD frame of this bluish color. Okay?
Yep.
That's approximately the simplest Matchbox shader that you can have, and we can actually break this connection even, and it will still render properly. And here comes a very important thing that you have to know about the Matchbox shaders. Now, normally, for example, if you're writing some JavaScript code and you want to see what's happening in your program, you have something called the console. So if we say on any web page, we say console.debug, and then we say hello, yeah, then it's going to print us the word hello on the console, or we can even do alert and say this is horrible. Okay, and then it's going to pop us an alert which says this is horrible. And this normally that's a very good way to check what the variables and the statements actually do when you're unsure what's going on. And Matchbox is peculiar in the sense that you cannot print any text from here. Okay, there is absolutely no way to output some debug message or another from the body of your shader, just none, zero.
So the only thing you can do is actually just bring it in and just test it like before?
The first thing you can actually bring it in and test it, whether it loads and starts. The second thing is you can lint and check it, and we're going to discuss it in a minute, how to do this. And the third thing, and the most important thing, is here you can see that we're assigning certain values to those colors. Okay, so we do 0.1 and 0.2 and 1.0. Now, if our shader works properly, then these are the pixel values which are going to arrive in our image, so we can actually measure them with something like, say, the color corrector. So we press C, we grab a color correct, and we connect it to our Matchbox output, and we look at the color corrector controls, and here you have the measurement color pods in the color corrector. So you say front, and it gives you a color picker, which determines which pixel you're going to sample, and we just press somewhere, and we see the values right here, but the values shown to us are integer colors. Okay, because you can see it's
not float.
25, 51, 255, etc. Now, as far as I know, this depends on the configuration of the project that you use, but internally, Matchbox only uses floating point color values. Okay, so I think if we put a lookup table here in between, and we actually convert it to 16 float, and we're likely to obtain the values that we're sending into the Matchbox shader. And we do, as you can see, so it's 0.09804, 0.2, and 1.0. Let's verify it with the values that we're actually outputting here. 0.1, that's close enough. This value doesn't match exactly because there are some tricky things as to how computers handle decimal fractions in general. So this is, as they say, it's good enough for government work. We know that it's the value that's coming across. That's a good one. 0.2, same thing. It's the one that we're supposed to have in there. and 1.0 full blue is also the one we're supposed to have in there. So we're all good. As we can see, we are generating a color frame. Now, what will happen if we actually omit one of these thingies? This is actually a funny thing which happened, which I've tried a while ago. By the way, what you can do, instead of deleting code that you don't want to execute, the fastest thing is usually just putting 2 common slashes in front of it so it doesn't do anything. And so now we're going to be assigning to RNG only. All you have to do to check your Matchbox shader again is you save the file. You see it's got this dirty icon on it, which means it isn't saved. So we save it, and then we go again to our node graph. We select the Matchbox node, and we click on the change shader, and we load our color shader again. As you can see, now we got a very interesting picture. You actually have to look at it channel by channel to understand what's happening. So we go Alt1. By the way, I'm always using the flame shortcuts because I started on flame. I know you, Joel, started on smoke, right?
Yeah, I'm on the smoke shortcuts.
Okay, so for you it's probably going to be different, but for me it's Alt1 to go into a single image viewport, which is more traditional for flame. And if we look at it, you see that there's some kind of junk going on in here, and all that junk looks to be related to the blue channel. And to confirm that, we can actually press Shift R to look at the red channel. Well, it's a pretty solid color, ain't it? Then we go to the green channel. It looks like the color that we've assigned. And then we go to the blue channel, and you will see that there's some junk in there. Okay, now that junk happens because in our shader we're assigning a value to the red, we're assigning a value to the green, but we are not touching the value for the blue, which might as well be garbage at the point when our shader gets processed. And that's the garbage that ends up in the blue channel. That's why our image looks like this. Okay, does that make sense?
Yeah.
All right, now let's pull this up a notch in terms of vectors. Now, GLSL supports a number of vectors, and vectors are you can use a number of different things in the vector context. Like the most standard way to look at vectors is just, I make this silent this time. Thank you very much. Yeah, the most standard way to look at vectors is just a point in say 3D space. So for example, a point in 3D space, which is positioned somewhere, has the x value, and it has the z value, and it has the y value.
Okay.
So if it is here on y, here on z, and say here on x, then we know that it's going to be like here and here. Okay. But for all intents and purposes, a vector is just a bundle of values. Okay, there are much nicer and better explanations of what a vector is in all the computer graphics courses and manuals, but for our intents and purposes, we know that a vector is a bundle of values. And these values are of a known meaning, which means that if you have a vector which is of x, y, and z, okay, you can also look at it as a vector of y, z, and x. But you just know that a certain value in that vector represents the x, another value represents the y, and another value represents the z. Does that make sense to you, Joel?
Yeah, you lose me a little, but I'm sure it'll make sense in a second.
Imagine that instead of doing something to one to just one number, we're gonna say we have to work with bundles of numbers all the time. So why don't we actually perform operations on bundles of numbers instead?
Okay, that makes sense. That makes sense.
So for example, we might say that we want to do this exposure change operation, which is multiplying every value by a certain amount. We could represent that in terms of vectors of RGB values, right?
Yep.
We can take a color and we can say that a vector of R, G, and B, which is a 3 vector, is actually a representation of our color. If we want to multiply each value in the vector by a certain number, we can see it as a vector scalar multiplication, which means that we literally create a new vector with every value of the initial vector multiplied by that number. So if we want to have a vector of R, G, and B multiplied by, I don't know, by X, say, which is just a number, not another vector, but just a number, then it's going to be another vector, which is going to be a vector of R multiplied by X, and then G multiplied by X, and B multiplied by X. Does that make sense?
It's becoming more clear.
Okay. The most important thing is that GLSL uses a number of uses these vectors in a number of places. It actually uses them all the time. That's why it helps to understand that concept of a vector early on. And for our usages, at least at this stage, we're just going to see a vector as a bundle of X and Y, or as a bundle of RGB. The most important thing is that we actually have to specify the type for the vector when we're creating it. Now, why don't we have any type declarations here, Joel? Do you follow this?
I'm not sure. I'm not.
Well, let's see. For what do we generally need type declarations? Like, we need them for the variables that we declare ourselves, right?
Yep.
But we don't have to declare types for the magic variables which OpenGL gives us, right?
Yep, because of the way the works.
Yeah, because they're already there. That's why they're magic. Okay. And here we don't have to specify a value because we actually specify that it's a float by putting this dot in here. Okay.
Yep.
See? Because if we put in a dot, when the shader gets parsed, the compiler understands, oh, okay, these guys put a number and a dot and a number, so that's why I should interpret that as being a floating point number. Okay?
Okay, so if they had no decimals and were single values, it'd be a normal integer 8-bit value, probably?
It would. Well, I don't remember exactly how many bits a GLSL integer has. I'm really ashamed of that. As I said, I'm not a graphics whiz. I'm just doing this like kind of an entertainment thing. But basically, what probably is going to happen is if we set this to 1 without entering this dot in here, and we save that shader just for the sake of it. If we'll look at what is going to happen, I think we need a little bit of organization here. Okay. If we grab a Matchbox and we'll load our color shader, it says can't load XML file, but that's all right. But the actual problem is that probably the source code of the shader is not being accepted.
Yep.
And there is a way to check the source code of your shader, and you should actually make a habit of doing that pretty early with the test shader program. Okay. Now, normally when you load Matchbox and you go to the, I'm just going to add this to my bookmarks so that we can get here quicker next time. Then you load it from this Matchbox directory, and this Matchbox directory is in the directory where your software is installed. As you know, there is a /user/discrete directory where all the Flame and Smoke versions get installed that you install on the machine.
Yep.
And some people don't know this, especially people who came in on Smoke on Mac, but this directory, user discrete, also contains a number of command line applications that you can use for different small tasks related to Flame or Smoke, and one of them is something that we're going to be using all the time, and this is called test shader. And how you get to it is you actually type /user and then press tab, and then you go discrete. DIS should be sufficient, and then a tab, so it throws us into discrete. Then we type Smoke, and which version that is, Smoke _2013, and again tab. And then right here in the directory where this where the smoke binary is installed, you will have a directory called bin, bin. Okay, as you can see, when we type bin and say tab, it auto completes, which means that this directory actually exists.
Yep.
All right, and then we want the program which is called test shader, so we type TE and then tab. There you go.
Cool.
You see, basically any computer where you have Smoke or Flame is going to have this. Once we've typed that in, we press return or enter or whichever you want to call it on this day of the week, and we're gonna see the helpful usage example. And what this test shader program will do is it's going to do the following. Like first, it does three things, which are kind of interrelated, but they're also like three separate distinct things. Like as you remember, we have our GLSL file, we have our XML sidecar file, and we have our proxy file. Now, the first thing that this test shader application does, it checks your GLSL file for errors, which is its main purpose, test shader, as is evident from the name. What it will do, it will take the source code that you've written for the shader, and it's going to try to build it, and it's going to tell you about any kind of errors that you've made in the code or things that you cannot do in a GLSL shader. And this is the basic usage hint that they are giving us. Test_shader, and then spacebar, and then the name of the GLSL file that you want to test.
Okay.
All right. So let's test our color shader, since we know that we are in the what is Matchbox directory next to our shader. Let's double check that. Yeah. So it's color.glsl. So let's say, yeah, to go up in my terminal history, I traditionally press the up arrow. For people who don't know this, like if you go like so, then you can go down. This way you can recall the stuff you've typed.
It's just like in Flame, right?
In the shell previously. That's just like in Flame and Smoke, yeah.
Yeah.
So it says test shader, then spacebar, and then the name of the GLSL file. So let's say CO, and then tab, so that it auto completes to our color.glsl thingy.
Yep.
And let's press enter. And then it says, oh, errors compiling the following shader. Somehow oh yeah, that's a very irritating reminder. Let's try it again. Gonna clear that out, and I'm gonna say test shader GLSL, and as you can see, it says compiling shaders, and then errors compiling the following shader. Blah 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 blah, and then it gives you the actual error message, and this one is the line number. Who could have guessed? And then you see what it tells us?
Float and integer. Yep.
So this means basically that on line 3, and this is one of the most important things in this whole coding game, is that you actually interpret the error messages in a sane way. It means that exactly on line 3 of our shader, which is this one, we are doing an incompatible type assignment. You see, it says incompatible types float and int in assignment and no available implicit conversion, which means that we're grabbing an integer value and we're trying to put it into a slot in a vector, which is supposed to be float. And since GLSL is relatively strict with types, it doesn't allow us to do this assignment because it says, oh, you want to put an integer somewhere where a float actually belongs. So what should I do with it? So that's why, to make it very easy for us, I've typed in 0.1. Okay? Does that make sense, Joel?
That makes sense.
All right. So one of the things that you have to get used to is to run this test shader. In general, you should run that test shader executable every time that you are changing the source code of your shader. It takes very little time and it's actually very useful. So that's the first thing that test shader does for us. Okay. The second thing that test shader does for us is test shader actually contains the actual updated manual for the Matchbox shader code. That is to say, it tells you which uniforms you can use and how you have to structure your shader for it to work. And you invoke this by saying test shader and then -- help, I think. Yeah, you see, it prints out lots and lots and lots and lots and lots and lots and lots of text. And my tip is when you have a command line program which outputs shitloads of stuff, you can page its output. So what I would usually do is I would grab test shader -- help, and then I would say space and then put on a pipe character, and then say space again and say more. And more is it basically receives lots and lots of text on its output, and it allows you to page through that stuff line by line. So if I say that, then as you can see, it outputs me a little segment of that manual, which is contained in the test shader, and then it stops at some point, and then I press enter to read through it at my leisurely pace. So here it shows you right at the beginning, it shows you XML structure, which explains you how to structure that XML sidecar file. And then if you scroll through it, you say shader section, output bit depth, how your shader should be interpreted, uniform section. These are all the types. You see, these are the types that we have talked about already. That's the float, that's the int. We also have the vec2, vec3, and vec4, which are all vectors of floats. And this specifies something called, I think it's called the cardinality of a vector. So it means how many values of that type you have in a vector. Like vec2 is for something like an xy value, a position in xy. A vec3 is for something like an RGB color or XYZ.
And then 4 would be RGBA, right?
Exactly,
like
exactly.
Cool.
So, and you scroll through that and you can read it. So this is the second use of the, and if you're in that paging mode, if you want to get out of it and back to your command line, you press Q, okay? So we press Q and we get thrown out of the pager. Yeah. So that's the second thing that the test shader program does. And the third one, which is actually something that you're going to be using also very often, but not as often as just checking whether your shader is valid, is right now, as you remember, we've had a little problem that we were assigning an integer value to somewhere where a float belongs, that is to the R slot of that vector, which is called GL frag color. So if we say that we want to test our shader, then it's going to say incompatible types float and int in assignment, so it's unhappy. And then we change our value back to a float value, and we save the shader and we check it, and then see what happens. It says compiling shaders, and then it outputs you the minimal XML sidecar file for your shader, which in that case doesn't contain anything at all, because you don't have any uniforms defined, you don't have any controls defined. Basically, as you can see, this shader already works for us without having an XML file alongside it, because it doesn't need any. But we could as well make a shader with some controls. and then it's really going to need an XML file, because the values for the controls are going to have to come from somewhere. I really want to touch on the subject of vectors a little bit, because they're so fundamental in GLSL that we're going to be using them all the time. So it's better that that you encounter them early and not late, and without any special values going in. First of all, as we already read in the documentation for the test shader, we have these types which are called vec2 and vec3 and vec4 and so on. Now, vec2 is a vector of two floats. So a vec2 is something like a float value and a float value. Like a vec2, for example, we can say that we want a vec2 which is going to be called my point. Okay, and then I think you can do that. I always remember, because basically for these typed values you have these so-called constructor functions. Like if you need to create something, sometimes you do have some syntax to create it literally from like a square brace or something like that. Sometimes you need to call a constructor function, and since I use a number of programming languages, I always forget which one I have to use in that specific case. But for our solid color example, what's actually important is to know that GLFragColor is actually a vec4. Okay, so GLFragColor is actually a vec4, which is mostly seen as being an RGBA vector. Okay, that's why when we what's important to note is that vec is for vectors of float values. Okay, and ivec, which is written like so, which we ain't going to be using all that much. Say ivec
integer, right?
So ivec2 is it's for integers. In that case, this works perfectly, because GLFragColor, the compiler and the GLSL subsystem already know that it's a vec4. That's why they allow us to assign to its components. Okay, and I think we could just assign to the whole color. We could say GLFragColor equals, and then we'll say vec4. I think that should work. Once again, GLSL is also not my primary programming language. Usually when I do something for myself, I do it in Python or Ruby.
Okay.
So a vec4 needs 4 values. So we're going to specify and say 1.0 for the alpha channel. We save it. And then we run our test again. And then you see compiling shaders, and it gives us the XML code. And when it gives you the XML code, it means that your syntax is fine. Okay, so now we can go into our shader clip again. And we can reach out for the directory where we were working. And we'll grab the color shader again, and we'll say load. And as you can see, it's outputting us the bluish color, but it's also outputting us an alpha of 1, which is the 4th value that we have specified in here. Okay?
Yep.
And you're using those vectors in a number of interesting ways, but the most important thing is that you can do something called partial assignment. And partial assignment is exactly the thing that we have done previously. So if you remember, we've done something like this. We said glfragcolor.r equals 0.5, for example, for gray in the red channel. You see, we got some junk in the green and blue, and we got some gray in the red channel, which makes sense. If we look at the red channel, we'll have this uniform 50% gray color.
Yep.
Right? Now, this works because the GLSL vectors support a concept called swizzling. Okay? And this is something to get used to, because pretty much all the shaders that you're going to be reading are using swizzling in one way or the other. And swizzling works for the case where you have a vector of a certain cardinality. Say you have a vector of 4 values like RGBA, but you only want to do something to a few of its values. Okay, so for example, here we want to assign to the R, which is the first dimension of that vector. Okay, and that's why we use the so-called dot notation, and we say dot R, and we assign the first value of the vector. But the funny thing is that I think that we could, with the same to the same extent, we could actually say glfraccolor.x equals 0.5. Okay,
because it's XYZ RGB
XYZW. So
okay,
if you look at it as if it were RGBA, then you can call it RGBA. If you look at it as XYZ, it's going to be XYZ and W, but it's the same thing. It's the vector which has like the first value, the second value, the third one, and the fourth one. Okay?
Okay. Yep.
And as you can see, if we load it, then we're going to be getting pretty much the same result. So, what swizzle means is that, as I've already said, GL fragment color is actually a vec4, okay? But we can actually replace a part of its values using a vector which is smaller. So for example, we could say that we're gonna have a vec2, and we're gonna make a vec2 of 0.2 and 0.8. I'm gonna check immediately whether I made any mistakes with that. No, I didn't. Yep. Okay, and then what you can do, this one is vec4, this one is vec2. Now if we just try to assign one to the other, it's probably gonna complain. Yeah, you see, incompatible types, vec4 and vec2 in the assignment, and no available implicit conversion. Okay, I agree, but when you use swizzling, you can say, you know what, I want to replace the R and G of this vec4 with the two values that come from the vec2. You dig that?
I'm getting it.
Mm? No?
It's so that will work now then.
Well, the thing is, this vec4 is a bundle of 4 values, okay? So we got like one value which we can call A, and we can have another value which is called B, and we can have another value which is called C, and another one which is called D, okay? Mm-hmm. But we can also call them R and G and B and A. Mm-hmm. Yeah, and we can also call them X, Y, Z, and W. And this syntax means that if we are assigning to RJ, it's telling that thing like, okay, you have a vec4 assigned to its first value and second value.
Yep. And
grab them from that vec2, because the vec2 has only 2 values, so that means that we're grabbing the first 2 values, like the two values contained in that vec2 in here.
Okay, so they'll be applied to the RG and it'll leave the blue.
Yeah, and the blue the blue in our case is going to be garbage, because this is an initialized pixel value, so it's probably going to contain garbage when we check this. Let me delete that junk in here, and then we're gonna test the shader. Yeah, it outputs the XML, so it means that it's gonna load. Now let's select the color again. And there we go, we get our garbage. And it looks like it gives us garbage in multiple channels, which sometimes happens. Yeah, it gives us garbage in the blue, but the red and green stay the same, as you can see in this.
Okay, yep.
In this controller here, in the color pots, in the color corrector, if we actually sample them. and they stay the same. It's just that there is this tricky thing with the viewers that when you're looking at a single color, sometimes this gets applied to one viewport but not to the other. That's why I prefer to work with a single viewport most of the time, like so.
Yep.
To not get confused, but it's doing what we wanted to do. So as you can see in blue, we still have that garbage crap going on, this one, and on and on the green we have the value that we're pulling in from here, 0.8. That's also why it looks predominantly green. And here's the value that we pull from the red channel, and that's the one we have assigned in here. So this is how swizzling works. So basically, if you have, the most important thing to know is that if you have two vectors, you have very fast ways to move values from one slot of one vector to the another slot in a different vector. And most of the stuff that you'll be working with, such as coordinates and colors, in the GLSL shader, they're going to be fed to you, packed into vectors. So it it makes sense to operate on them as vectors. I say let's take a little break, and in the next installment we're going to look at making a gain Matchbox shader.